Bismillahirrahmanirrahim. Today I'd like to talk about something called synthetic substitution. Synthetic substitution. Synthetic substitution is a tool. It's like a trick and something easy, a process that helps us solve problems, okay? So what does this mean? Okay, for example, if I give you a function f of x equals 2x squared minus 3x plus 5, okay? If I suggest to you that f of x is that, okay? And what they ask you, what is f of 2? Well, that's easy enough, right? That means what's the value of the function when you substitute 2 for x? So when it's like 2 squared minus 3 times 2 plus 5, okay? So that's going to be like 2 times 4 minus 6 plus 5. That's 8 minus 6 plus 5. That's 2 plus 5, and that is 7. I hope I did that right. So we can say that f of 2 is equal to 7. In other words, if we were to graph this over here, the ordered pair 2 and 7 would be on this graph, okay? So if we wanted to find out what f of 2 was, okay, we basically just substituted that in the function to find the value, right? That's easy enough. Okay, but what if, now we're talking about polynomial functions, which can be quite big. What if the function was this? F of x equals x to the 4th plus 2x cubed minus 13x squared plus 15x plus 22. And I asked you to do f of negative 5. That's going to be a bit of a beast, right? Because then we have to substitute that over here and over here and over here and over here, right? So it's going to be kind of challenging. So that's where synthetic substitution is very helpful. Synthetic substitution allows us to substitute this over here like in a short form and kind of get like a shortcut answer of this, okay? So effectively we would be substituting that, okay? So how do we do this? Okay, so before I do that, if we were to substitute it, this is what we would have to do. Negative 4 to the 5th plus 2 times negative 5 to the 3rd minus 13 times negative 5 squared plus 15 times negative 5 plus 22. That's what we would have to do, okay? And that's going to be tough. You have to get your calculator out and still you have to be worried you don't mess up, right? Okay, so this is how you do synthetic substitution. Okay, the first thing you do is you just write all the coefficients down for the function. Okay, so that's what we're going to do. So 1, 2, negative 13, 15, and 22. You have to be careful if any of the terms are missing. Let's say if this was missing, there was no negative 13, there's a term missing, then you put a 0 in its place, okay? So you write down all the coefficients, okay? And then what you do is, this is what I do anyways, you make a line over here like this, all right? And then you make a line like this, okay? Some different people do it differently. Some people just go like this or something like that, or negative 5 like this and over here, okay? That's good enough too. So whatever works. Okay, so we're going to substitute negative 5, right? So we put the negative 5 over here, okay? And then you do this. This is just to make it neater so you don't mess up, okay? Now, synthetic substitution is doing all of this, but in a shortcut, okay? All right. So you have to be very careful. The first thing you do is you just bring the first coefficient straight down. You don't do anything, okay? Just bring it straight down, okay? Be careful. Don't put anything over there, okay? Just bring it straight down. Just bring the 1 straight down. Just drop it, like over here. And then what you do is you multiply these two terms right here. Negative 5 times 1. That's negative 5. And you put it right here. Negative 5. Negative 5 times 1, negative 5. And then you add these two terms. Okay, then you add those two. That's negative 3. And then you take this one and you multiply those two again. Okay, so negative 5 times negative 3 is 15, and you put it right there. Okay, so negative 5 times negative 3 is positive 15, and then you add these two terms. Okay, that gives you 2. And then you multiply. It's like multiply, add, multiply, add, multiply, add, right? So negative 5 times 2 is negative 10. And then you add these two. You get a 5. You multiply it and get negative 25. And then you add and you get 3. And this is the answer. In other words, if you were to do all of this, you would get 3. F of negative 5 is 3. Okay? So after you've done with this, I for the time being, I'd like you to do this, okay? I want you to say f of negative 5 equals 3, or 3, or negative 5 and 3 is an ordered pair that would be on that function. I'd like you to write it like this, because there's value in this and it will help us in the future, okay? So that's pretty impressive if you think about it, right? Instead of doing all of this math, we almost did almost like a mental math. It's pretty magical in a way. Okay, so let's do this process one more time so you get this, all right? So the first thing you do is you just write down all the coefficients and just fill in the zeros if there's any terms missing. Okay, we'll get one of those questions. And then you just bring the first term down. Don't mess with the first term. The first term you don't mess with it. Just bring it down and put it right there, 1. And then you multiply, add, multiply, add, multiply, add. That's all you do. Multiply negative 5 times 1, that's negative 5, just put it right there, and then add negative 3. Multiply 15, and then add, you get 2. Multiply negative 10, and then you add, you get 5. Multiply negative 25, and you add, and you get 3. And that is the answer. So f of negative 5 is equal to 3, or negative 5 and 3 is an ordered pair that's on this function. And as I suggested, I would request you to write it like this. Okay, that was pretty cool. So if you wanted to do this, you do all of this, and trust me, you get 3. All right. Okay. So that's one example. Let's do some more. Okay. How about this one? This one is I found this on the internet. Some generous solve. F of n is equal to 5n to the 5th minus 6n to the 4th minus 5n cubed minus 10n squared plus 5n plus 10. Now what we need to find is f of 2. Imagine substituting 2 and all of that, right? So we're not going to do it, right? So we're going to do synthetic substitution. Hey, synthetic substitution. Okay, cool. All right, so 5, negative 6, negative 5, negative 10, 5, and 10. Okay, I wrote them all down. Now, none of the terms are missing here. Okay, there's 5, there's 5, there's 4, there's 3, there's 2, there's 1. So they're all, none of them are missing. Okay. Notice, of course, I write that one down too. Okay. And I want 2. I'm substituting 2. Okay. Now, notice when I do this, you give yourself some room over here to work, right? Don't make like like this, and then you like putting tiny numbers over here, and make mistakes, right? So don't make it like this, and you put small numbers, and you get screwed up. So just give yourself plenty of room to work there, right? Progressive logical reasoning. Okay, so don't mess with the first coefficient. Just bring it down, right? So bring the 5 down, and then multiply, add, right? So 2 times 5 is 10. Put it over there. And then add, you get 4. 4 times 2 is 8. Then you add, you get a 3. 3 times 2 is 6. You put it over there, and you add, you get negative 4. Then multiply, negative 8. So negative 8, so that's negative 3. 2 times, that's negative 6. The answer is 4. Okay, so that's the answer. So f of 2 equals 4, or the ordered pair 2, 4 is on is one of the points on the graph like this. Okay, you got that? Okay. Now I like to do one more. I actually like to do 2 more before we finish. Do this as f of x is equal to 2x to the 4th plus x cubed minus 11x squared minus 4x minus 12. and we are asked to find what is f of 2. Okay, let's do this. Okay, I'm just going to write the coefficients down. 2, none of them are missing. Like this. And I want f of 2. Alright, let's do this. So just bring the first one down. Don't mess with that. So 2 times 2 is 4. That's 5. Add. 5 times 2 is 10. Add negative 1. 2 times negative 1 is negative 2. This is positive 12. So 4 makes negative 6. 2 times negative 6 is 12. Negative 12. And positive 12 minus negative 12 is 0. So here we get the answer. That means f of 2 is equal to 0, or the point 2, 0 is on the function. This is very important. Okay? Got that. Easy enough, right? That was kind of cool. All right, let's do one last one of synthetic example. Maybe perhaps you can do this on your own. After you can pause it and then see if you get the same answer. 2x to the 5th minus 14x cubed plus 24x, and we're asked to find what is f of 3. Okay, now here we see we're missing some terms. Okay, what do? Panic? No, we just write the coefficients. Okay, so that's 2. Though the x to the 4th is missing, so we're going to put a 0 in its place. Here we have negative 14. And x squared term is missing, so we're going to put a 0 in its place, hold it in there. And that's 24. And then the last term is also missing, so you put that in there, so there's a 0. So you have to put that one over there too. Very important. And then we're trying to find f of 3, so we put that over there, and then you can put this line over here. So we just bring, I kind of made this line kind of very low, didn't I? So it's too much space. Okay. All right, let's do this. Bring the 2 down. Don't put anything there. So 3 times 2 is 6. Add them up. Multiply, that's 18. Add them up, you get 4. That's 12. Add them up, you get 12. 12 times 3 is 36. Over there, add them up, you get 60. 60 times 3 is 180. Add them up, you get 180. And that's the answer. So in other words, f of 3 is 180, or the ordered pair 3 and 180 is a point that is on the graph of this function. Okay, so this process is called synthetic substitution, and it's really, really cool because it lets you calculate the values of f of x in much faster way, because we're going to need to do this in this chapter a lot, and this is an important skill to master. So I hope you do all the homework problems and worksheets with due diligence so you get good at it. Until next time, assalatu wassalamu ala rasulillah wa ala alihi wa sahbihi. Assalamu alaikum.